So this is taken from the first worksheet in Unit 9, and we're looking at finding volumes of solid figures. First one is number 5 from that first worksheet, and it says find the volume of the truncated cone which is created from the given right circular cone. Okay. Recall that the volume of a cone is 1/3 the area of its base. Here our base is the circle, so pi r squared times the height. And so the first thing we're going to do is plug in those values for the larger cone and find the volume of the larger cone. So plugging this in, we get 1/3 pi times 6 squared times 15. Punch that into your calculator. So I'm going to type in 6 squared times 15 divided by 3. Don't multiply the pi and leave the pi alone, and you end up with 180 pi. So that's for the volume of the large cone. Now in order to get the truncated cone, we're going to have to cut the top off. When you cut the top off, the top itself is a smaller version of the larger cone. And in fact, the two figures are going to be similar because they're coming from the same exact cone. And so we see that what's left is a height of 10 if we're looking at the truncated cone on the left hand side, which tells us the height of the smaller cone is 5. And so if we compare heights, we get so we'll go small to large. We have a 5 to 15 ratio, or we can reduce that 1 to 3 ratio. So if we compare volumes, and we'll go small to large, well, heights are one-dimensional, volumes are three-dimensional. So to move from one-dimensional to three-dimensional, you cube it. So I'm going to cube, it's going to be 1 cubed to 3 cubed, which is 1 to 27. So that tells me that the volume of the larger the volume of the larger cone is 27 times bigger than the volume of the smaller cone. So we can quickly get the volume of the smaller cone by taking the volume of the larger cone. I'll put V with a little s for volume of the smaller cone, is the volume of the larger cone, 180 pi, divided by 27, because it's 27 times smaller. And we can reduce that. If we divide top and bottom by 9, we end up with 20 pi over 3. As a decimal, we get about, I'll round it, 6.7 pi. If you had trouble seeing that we should divide by 27, another thing we could do is, well, when we're comparing volumes, we can set up a proportion. We could say the volume of the smaller divided by the volume of the larger is 1 to 27, and you can cross multiply and you get 27 times the volume of the smaller is the volume of the larger. And so if we're solving for the volume of the smaller, you divide by 27, and you see that the volume of the smaller is the volume of the larger divided by 27. And so that's how I knew to divide by 27. So now let's put this together. What we're after here is the volume of the truncated cone. So the volume of the truncated cone is equal to the volume of the larger minus the volume of the smaller, which is 180 pi minus roughly 6.7 pi, which is about 173.3 pi. And if you multiply pi into that, we get 544, roughly 0.4, and we're talking about cubic units. Number 6, we have a truncated pyramid this time, and so we're going to kind of work through this the same way. We know that the volume of the truncated pyramid is the volume of the large pyramid minus the volume of a smaller pyramid, which we get when we truncate it. Okay, truncated meaning we're going to cut the top of that pyramid here, and we end up with a smaller pyramid. The top part that we cut off is a smaller pyramid. What we do know is the height that's left over is 4, and we don't see the original height of this pyramid. But if you look at the part I'm going to highlight, you see a right triangle. Which we can use to find the height of the large pyramid. So let's let h be the height of that large pyramid, and we know that h squared plus 6 squared is equal to 10 squared. The square of the sum of the squares of the legs of a right triangle is equal to the square of its hypotenuse. So h squared is 100 minus 36, which is 64. So take the square root, and h is the square root of 64, which is 8. So the height of the larger compared to the height of the smaller, well, the height of the larger is 8, and the height of our smaller, well, if the bottom part's 4, and then the top part's got to be 4, so 8 to 4, which we can reduce to 2 to 1. So that's one-dimensional. If we compare the volumes, we don't know them yet, but the volume of the larger compared to the volume of the smaller, which is three-dimensional, so we're going to cube those. So we take 2 to the third power and 1 to the third power, so it's 8 to 1. So if I say, well, the volume of the larger divided by the volume of the smaller is going to be 8 to 1. If I cross multiply, I get 8 times the volume of the smaller is equal to the volume of the larger. Divide by 8, and the volume of the smaller is going to be volume of the larger divided by 8. We'll come back to that. So let's find the volume of the larger. In general, the volume of a pyramid is 1/3 times the area of its base. It says this is a square pyramid, so the length of this base is going to be 12 because half of it is 6. So this is a 12 by 12 square. So we're going to say 12 times 12, that's the area of the base, times the height, and we found the height of the larger pyramid is 8. So plug that into the calculator. 12 times 12 times 8 divided by 3, and we get 384 units cubed, and that's the volume of the larger pyramid. The volume of the smaller pyramid we said is the volume of the larger pyramid, which is 384 divided by 8, which is exactly 48. And so now we can find the volume of our truncated pyramid. It's the volume of the larger, which is 384, minus the volume of the smaller, which is 48. And we get 336 cubic units. Number 8, we know that the volume of our cone is given. The radius of the lower base is given at 9. And we want the height of the original cone. The height of the truncated cone is 6 centimeters, and the radius we don't know. Okay. So again, we're gonna break this up. We got the large cone and the small cone. The small cone is the part we don't see. It's the top here that was cut off. Okay. And so we're looking for the radius of the small cone. We have the radius of the large cone. Let's see, what can we compare? We have so we got the radius of the large compared to the radius of the small. We know the radius of the large is 9. We don't know the radius of the small, so I'll call that x. So that's one thing, we're looking for x. We got the height of the large compared to the height of the small, and we don't know either of those. Okay. We got the volume of the larger compared to the volume of the smaller, and the volume of the larger is 486 pi centimeters cubed. We don't know the other, I'll call that y. Okay. But we do have a formula for the volume of a cone. So the volume of the larger one we know is 1/3 times the area of its base, which is pi times r squared, so 9 squared, times the height. And so that's going to give us the height of the larger cone. plug that volume in. We got 486 pi equals 81 is 9 squared, divided by 3 is 27, pi times h, divide 486 pi by 27, and we get 18. And that's the height of the larger cone, so we know that's 18. And now we know the height of a smaller cone. The height of our smaller cone is, well, the truncated part is 6, so if the full height is 18, right? So this full height is 18, and we cut it, so there's 6 left on the bottom, so what's left on the top is 12. So we have the height of the smaller, and we can reduce that ratio, divide by 6, and we get a 3:2 ratio. And so now we can find everything else we need. So if it's a 3:2 ratio, this is one-dimensional. So is the radius. Radius is also one-dimensional. And so we know that the ratio of the radii are going to be this. It's going to have the same ratio for the heights, and that ratio of the heights is 3:2. So we know this is also 3:2. So that we can set up a proportion here to solve for our missing radius. We could say 9/x is equal to 3/2. You can cross multiply and get 3x is 18. So x is got to be 6. And so let's see if we found what we were looking for. The height of the original cone, we got, so the height of the larger cone is 18 centimeters. We wanted that. And then we wanted the radius of the lower base, no, the radius of the upper base, which is the radius of the smaller cone, and we found that as 6 centimeters.